So let's start talking about the weather a little bit here. Uh, I wanted to give you an overview this week of just kind of what meteorology is, what we're going to be talking about, just some general aspects of it. So, title is Monitoring the Weather. So, what are some of the basic characteristics of the atmosphere and the weather? Uh, if you looked outside today, you would probably say, "Oh, what is it? Is it raining on me? Snowing on me? Is it cold? Is it warm? Is the wind blowing in my face?" All of those are aspects of the weather, of meteorology. So that is basically what we're describing here is the state of the weather at a given place and time. So if you walked outside and described it, if you came back 10 minutes later, it would be different. At least to a degree, it would be. So the idea is that if we want to describe the weather, we need to have it all at the same time. We need to know the temperature, humidity, clouds, precipitation, wind, all of it at the same time. And meteorology is just the study of the atmosphere and what causes the weather. What we're going to be, why, in other words, is that temperature so cold today? Or why is that wind blowing hard? That's what we're going to be talking about. Climate is long-term averages. And climatology is really the study of climate itself. What controls it? What dictates our climate? In keeping time in the weather, we use universal time, which is basically Greenwich, England time. The idea is that if I take an observation at 7 a.m. in the Eastern time zone here, for example, and I took one at 4 a.m. in the Pacific time zone, they are exactly at the same time as far as over the globe which is concerned. So if we use universal time and say, oh, I want to do it at 12 Zulu time or 12 universal time, that would be the equivalent of 7 a.m. Eastern time, 4 a.m. Pacific time. So every one of the observations around the world would be taken on that given moment in time. That would be how we would describe the weather at 12Z. If I want to describe it at 13Z, I need to move my times everywhere up by an hour. We're at two basic kinds of weather systems. We have high pressure and low pressure. Low pressure generally brings in bad weather. High pressure generally brings in good weather. The winds around low pressure in the northern hemisphere, notice I said northern hemisphere, the winds around them flow counterclockwise. So if you were to look at the way a clock rotates around, then we go the opposite way. The same high pressure rotates clockwise. So here you can see that. So if I am to the, we'll say this is traveling north and I'm northwest of the low here, I'm going to have northwest winds. If I'm to the southeast of the low, I'm going to have southeast winds. High pressure, if I'm to the northeast of the high, I'm going to have northwest winds. If I'm on the west side of the high, I'm going to have some kind of southerly winds. Air masses. Air masses are huge in the sense that they cover thousands of miles and they have similar conditions. Think about if you went over Canada this time of year, there would be snow pretty much over the whole country, not that much sunshine. Temperatures are going to be cold and dry. Snow is not exactly putting a lot of moisture into the atmosphere. There's no lakes, no big oceans up there. So it's just a cold, dry air mass. All temperatures within about 5 to 10 degrees of each other. Relative humidity is very little difference. So that is a Canadian or Arctic continental polar air mass. Now, if I took you down over the equator and over the Atlantic Ocean, what would you have? Well, you'd have a pretty warm air mass, lots of heat from the ocean, lots of moisture from the ocean. So I have a tropical maritime air mass there. So you can see how, depending on where you are in the globe, these air masses form. Interestingly, where the air masses come together, there are fronts. Simple definition: if the warm air is advancing, it's a warm front. If the cold air is advancing, it's a cold front. Warm fronts are not as steep as cold fronts, so they tend to have more prolonged precipitation and maybe, not as quick a transition in temperature, where cold fronts can be very sharp, very quick transition. So some of the things we might want to know about the weather, if I was describing it, I want to know what the max temperature is or the min temperature. What's the chances of precipitation? Air pressure. You're going to talk about a lot about that throughout this course. All it is the atmosphere's weight of air on you. Wind direction and speed. Clouds. Clouds are just a large area that are visible water in the sky. They're literally droplets of water or ice that have developed in the sky. So they can be wispy, like on the left here. That wisp is ice because that cloud is made up of ice crystals. The one on the right's a little lower. Looks a little darker, doesn't it? More water vapor. Water itself, liquid. And we have other types. Stratiform clouds tend to be uniform, horizontally long sheets of clouds. So the air is ascending pretty gradually over a large area. Cumuliform clouds, kind of puffy. They look like cotton balls. I kind of like watching them because they're always kind of changing shape. And when the clouds come together, sometimes cumulus clouds come together and form cumulonimbus clouds. So now that we've kind of observed a little bit about the weather, I wanted to look at what's going on today. This actually is 18 hours ago. This is a surface weather map. You're going to see a lot of these. So you might as well get used to looking at them. You'll notice H's, you'll notice L's, you'll notice lines with triangles and half circles on them. Each one of those is important. How are these created? Well, I talked about having the weather plots. There are hundreds of stations across the United States, thousands across the world, tens of thousands probably, everyone taking an observation at the surface at that time. And we plot that. And what you're looking at here is a map describing where the lowest pressures are, the highest pressures are, and where air masses come together. They are significant because that's where the most active weathers are going to occur. So at this time, we have low pressure over Louisiana, high pressure over the mid-Atlantic United States, another cold front up to the north. You can see the blue triangles. There's a cold front, and north of that, we have temperatures literally 20 degrees below zero right now. So how does this change? Well, if I evolved it 9 hours, move it from 18 hours ago to 9 hours ago, well, I have now a warm front or a stationary front right along the east coast. Stationary means that the front's not really moving. There's a contrast in air masses, but it's not going anywhere. And I have a warm front moving into the state of Florida. If I move up to the current time, what do I see? Well, I have strong high pressure north of New England, 1030 millibars, which is a unit of measure for pressure. I have low pressure on the west coast coming in over just north of Washington State. I have a cold front dipping into the plains. You can see the barbs here, blue and triangles, and that's the triangles point in the direction of motion. Here I have a warm front moving in from the southeast, coming in off the Atlantic Ocean. There's warmer air, more humid air coming in this way. Cold air is over here still. And here's the low that started out in Louisiana 24 hours ago, now up to here. That low is going to intensify as it's moving north and cause really the first significant snowfall in several years for parts of the Northeast. And we make a forecast on that. And that is the forecast, literally, of what this is going to look like. The low has moved north and intensified. Warm front pushed in, cold front to the south of it. High pressure coming down. We saw that cold front here in the Midwest moving in, getting colder there. And then areas of precipitation associated with this low. So that is just an overview of a surface weather map. I wanted to give you one other thing we're going to talk about is upper air weather. What's an upper air weather map look like? This is 300 millibars. Think of it as being about 25,000 feet up in the atmosphere. It's a jet stream. You hear lots of reports about the jet stream all the time. Here's a very strong jet streak coming in off the west coast of the United States. There's another jet streak here moving up through the northeast United States, associated with the big low that's coming through. So this is if I was flying an airplane and wanted to make a fast trip from from Washington State to Florida, for example, I've got a real good jet here. I just ride it right on through here, and it's really going to help me move along quickly. So this is an upper air chart. It reflects what's happening in the upper air. And finally, I wanted to show you a radar chart, which is just showing you what's going on radar-wise. We can see here a lot of enhanced rainfall in this area. You'll notice that it kind of looks pretty much not really a lot of color difference back in this area, and that's more due to snow not being all about the same color. So there's more heavier snow back in here, in this area especially. I wanted to also give you a quick look at how things are going to change. This is a forecast model. We're going to not get into details on how they're made or whatever, but we do have lows in the upper atmosphere, and here's one over Hudson Bay, counterclockwise winds, more of a high pressure off the east coast of the United States or over off the southwest part of the U.S. as well, and the jet streak still coming down and up and through. So you can see it's very wavy pattern in the upper atmosphere. So this is what I wanted to just talk to you a little bit about, just give you an idea what this course is going to cover. So hope you got a little bit out of this, can answer the questions you're going to see this week, and please don't hesitate to ask me if you have any questions.